Let us solve the exercise number 6 in the part B of data structure lab. In this exercise, we are supposed to write a program to evaluate a postfix expression. First, let us understand what is the meaning of this. So we are given a postfix expression like we have a 4, 5, 6 star plus, and we are supposed to evaluate that particular expression. So how do we evaluate this 4, 5, 6 star plus? So you first take the first operator here, that is the star, and take the first two numbers over here, that is 5 and 6. So what you get is 5 into 6, whatever answer you have it. And then the next thing that you are going to do is you take this 4 and apply the last remaining operator, and that is going to be plus. So this is going to be 30, and 30 plus 4 is going to give you 34. So you are given an expression of this type, that is postfix expression. You have to evaluate them and give the final answer. So this expression will be generally given in the form of a string, or in other words, you will be given an expression in double quotes. For example, you will be given an expression 4, 5, 6 star plus and this. So everything within this expression will be string, and you know very well the last character of any string will be this string terminator, that is the null character. So this, you are familiar with the C programming language. How do we solve this particular problem? What is the solution for that? So what we do is we are going to use a stack. Whatever the string that is given to us, we take one character at a time, and we push them one element of this particular expression that is given to us, and we are going to push them into the stack. One very important thing that you must understand is that this particular exercise assumes that only single digit numbers are added. So for example, you have this 4 plus 5, or single digit 4 plus 5 into 7 something, single digit is there. We are not adding two digits like this, or 2 plus 1 digits or something like that. So we are just assuming, I am assuming that only one digit will be there within the number. We are not using two digit. For two digit, you have to first extract the digit and then do it. So that problem becomes slightly complicated. So let us first start with the given expression. So you are given an expression. What we are going to do is we take one element of this expression. We assume that this is the one. We will push them into the stack. Okay. So we take the first element, that is element at a of 0. We take that element and we push them into the stack. Okay. So when you push it, the stack pointer, you know very well, will move to here. We take the next element and we'll push them into the stack. Definitely the stack pointer will also move accordingly. Okay. We take the next element and also we will push them into the stack, and the stack pointer, as you are pushing, the stack pointer will move to the top. Okay. Now when we try to push the next element, we notice that the next element is not a digit. All of them were digit. So when the given elements were numbers or digits, we push them into the stack. But now what we have is an operator. So star is an operator, multiplication operator. We are familiar with that. So what to do in this case? Now you know very well multiplication is a binary operator. So we need, in order for us to use this star, we need two numbers. So that means that is why it is called as a binary operator. So we need to have the first number and the second number, or the first digit and the second digit. So where are those digits? They are there in the stack. So we will pop the element from the stack and then we will place them here. So what we are going to do now is, because we need two operand, we are going to pop the element 6 here. Okay. and we are going to pop the next element, that is the 5 here, and we will operate on them. So when we operate on them, that is 5 into 6, so you know that the answer that what we are going to get is 30. Okay, this 30 we are going to push it back to the stack. So the stack pointer will now point to this 30. So now let me just make it as a proper. So this 30, slightly increase it. Okay, so this 30 is there here. That is the 5 into 6. Now again what you notice here is the next one is again an operator. So when it is an operator and it is a binary operator, we need to get the two elements. Again we are going to pop this 30 from the stack. We'll place it here. Also we will pop the 4 from the stack. Now it is 4 into 4 plus 30, so that is going to be 34. So this 34, we will again push them back to the stack, assume that the stack pointer will move accordingly. So now this is the final answer. Now you notice that the last thing is the end of the string character, that is the null character. So we end by saying that we have evaluated the expression and the final answer for this expression is the one which is there in the stack. We will pop this one again outside and we will print the value of 34, and definitely the stack pointer will go back saying that there is no element in the stack, and we will print this 34 and say that that will be the value of this expression. So this is how we are going to do. So what we are doing is whenever we get a number, that is digit, we are going to push them into the stack. So whenever there is a digit, that is the number or a digit, we will push them into stack. Whenever we encounter an operator, we will pop the two elements from the stack. We'll pop two elements from the stack. We will operate on them. If it is a star, we will multiply it. If it is a division, we will divide it, and so on. So depending upon the operator, we will perform. The result, whatever we get, that again we are going to push them back to the stack. Again, we will continue this same process until we reach the end of the string. When we reach the end of the string, that is the end of our evaluation, and we will pop the last element which is there in the stack to say that is the final result of evaluating the expression. So this is what we are going to do it. So let me quickly rearrange them so that it matches this part. Just a minute, and this is what we have here. So very small expression what we have here, and this is not required. Let me delete this one and let me make it look like a stack by just giving it a border. Okay, so this is what we have. So what we need is a stack, and in stack we have two operations. What are the two operations? One is the push operation, the other one is the pop operation. So when you are trying to push an element, we have to know which element is being pushed, and when we pop up, we must know which element is being pulled out. So let us quickly write the program for creating a stack. I'm going to go to the my code block here, and I'm going to click on the file, and I'm going to say new file, and I'm going to select C and C++ as my source file. Let me click next, and I want to C program. Let's go here and select the location where you want to write the program. I want to say evaluate postfix. You can give any name, but please don't give the spaces in between the file name. Make it as a single file name, and let me just finish it off. As usual, for writing any C program, you need a stdio.h. So I'm going to include the stdio.h file, and let me define a constant here, and that constant I'm going to call it as max. Max is, I will take it as 50. So what is the meaning of this max 50 is I have a stack. So I have the stack. The maximum size of this stack is 50. So you can push up to 50 elements into the stack. So that is what I said. During the examination, definitely you won't go beyond 5 characters, but just for brevity, I've just taken that as 50. You can reduce it, and it's not going to make any difference in the program. So let me create the stack. I'm going to call this stack as yes, even though I've taken the variable as a here, but I will call it as yes to make it as a stack. So stack of maximum characters. So this is my stack, and you know very well for the stack, there is one pointer that always points to the top of the stack. Initially, that pointer will be pointing outside the stack, and in other words, it will be pointing to the index which is less than 1, and the index is -1. So I will initialize this top as -1, indicating that initially the stack is empty. Let us write the program to push an element into the stack. So I want to push the element x into the stack. So let's say x is any element. So for example, if x is 4, I want to push that element x into the stack. How do you do that thing? In order to push an element into the stack, first you have to move the pointer top and then put the element over here. However, when you are trying to move an element, if you find that stack is already there at the maximum value, so in this case the maximum value is 9, but suppose if the top pointer is already there at the maximum location, then you cannot push any more element. We say this situation as overflow. The stack is already full. Anything you put on top of the stack will be overflowing the stack. One important thing, in C, the array's index starts from 0, and the last one is 1 less than the total number of elements. So you know that thing. So here there are 10 elements. The stack size is 10, but the indices starts from 0. So 0, 1, 2, 3, 4. The last indices will be 1 less than the maximum number of elements. So what is the maximum element number of elements of this stack is 10. However, the index is 1 less than that. So when the top is pointing to 9, that is the index of the array, not the total number of elements. When the top is pointing to max -1, if this maximum is 10, you know very well, totally 10 elements are there, 10 minus 1, that is 9. If the top is pointing to 9, then you cannot put any more element because it will end up in overflow. So let us first handle that part here. So if the top is equal to max -1, that means the stack is already full. So we are going to print and we are going to say print and we are going to say, what is this? What has happened here? Okay, we are going to say stack overflow. Okay, stack overflow, and we will not proceed with the evaluation because once the stack is full, when you know the main part of this entire program is the stack. If the stack itself fails, then there is no point in evaluating. So we are going to just exit this program, and we will give a code -1 to the operating system saying that this program failed altogether. Otherwise, what we are supposed to do? Otherwise, we have to first move the pointer, that is the top pointer, to the next location and then push the element here. So how do you push put the element 5, that is the number 5, into the stack? First move the pointer, increment the pointer, and then put the element here. How do you put the next digit 6? First increment this pointer. So pointer is currently pointing at 1. Increment this pointer. So the pointer will now point to the 2 here. So move the pointer, that is increment the pointer, and then put the element at that location. So how do we write that thing? So we will first, S is my stack. We will increment the top and then put the element. My element that I am interested in is X. So this is the element, and this is the element I am putting at the top location. So this is regarding the push here. Now let us try to pop an element. What is the meaning of saying pop an element? Popping means pulling out one element. You must know which element has been popped out of the stack. Now, because we are talking about the integer, so this particular function will return the element that is popped out. So I'm going to say pop, and it's going to return an integer value because that's a value that is popped out. So integer value, one integer value will be popped out. So the return of this function is an integer. So how do you pop the element? So very important thing over here is when you try to pop the element. So let me put it here. So let me put them here. So when you try to pop an element, if you find that the stack is already empty. So let me first make it look like a stack. So if you find that stack is already empty, what is the meaning of saying stack is already empty? The top pointer is pointing at the -1 location, which is less than the first element of the array. So that means there is no element in the stack. So we say this situation as underflow. So we first check for that thing. So if the top is -1, in that case, we will printf and we are going to say that stack, let me just make it here, stack underflow, okay, or stack is empty. It's up to you. If you want to use the technical word, say underflow. Otherwise, you say stack is empty as a common word. And there is no point in continuing with the program. I'm going to exit the program with the -1 as the code, indicating the operating system that this program has crashed. So -1 indicates to the operating system that there is something wrong with the code and it didn't completed successfully. You can use anything or you can just leave it blank. It's up to you, but I'm going to use -1. Okay. Otherwise, let me just push the element here. Otherwise, so let's assume that the stack has 3 elements here. Suppose if this is the case, how do you push the element? Now this is the top of the stack. So assume that there are 3 elements in the stack. How do you pull out the element, or how do you pop the element? First, you remove this element. So remove this element of the stack and decrement the top pointer by 1 because one element has been removed. So how do you remove this element? Again, pop out this element, remove this element, and decrement the top pointer. So this is what we are going to do. So let's try that thing. So we are going to remove this element. So we are going to return the element which is there at that particular location. So S is my stack, and I'm going to return the element which is pointed at by the top. So for example, I'm going to remove the element. So the top is pointed towards this element 4. So whichever element is that is pointed by the top, you remove that element. So you return that element. That is what I have written. And after this, you decrement the top pointer. So how do you decrement? After that, so after that, you decrement the pointer. So this is as simple as that. Okay, done with it. So now let us go with the important part of this one, and that is the evaluation. So let us try to evaluate the expression, and I'm going to write a function for that, and I will call it as evaluate. Okay, and what is that we are supplying to this evaluate? So we are going to supply, let me put the 4 was here, 4 5 6, I think that was the 4 5 6 was the number. So we are going to give a string here. So we are going to supply a string. So this function is going to take a pointer to a set of or array of character. In other words, it is going to point to a string. So let me call that one as expression EXPR. You can give any name, okay, STR, anything you can call it. I will just call it as expression because they said they evaluate the expression. So this is the expression. What is the expression? What is Given here is a string, for example 456 star plus. A string is supplied to this one, okay? And we are going to evaluate this one. So how do you evaluate the expression? What we are going to do is we are going to take one element of this. So this whole thing, it is not a now. So the name that is given is expression. So you take the first element of this. Instead of a, I am calling it as expression. So expr of 0 will return the value 4. Okay. So similarly, expr of 1 will return the value 5, and so on and so forth until I reach this null. So you start from I is equal to 0, then I is equal to 1, then I is equal to 2, 3, 4, and so on until the return value or until the element is null. In that case, just stop the string. Null means the end of the string. So I need to use a for loop. I will use a counter variable I here for my for loop. So let me go here and start the for loop. So for I is equal to 0, you know very well. So whenever you are using the pointer, so the I value will start from I is equal to 0, then I is equal to 1, then I is equal to 2, and so on and so forth up to the end of the string until you get this null string. So when do you stop this one? You stop until expression of I is equal to null. So in other words, you continue the iteration, or you continue this loop. You can keep on executing this for loop until you encounter this null character. Now there is no need to write this whole story here. This is equivalent of writing single until expression. What is the meaning of saying expression is anything like 4 is there. 4 has the ASCII value something like 52 or something. Okay, 5 has some ASCII value. What is the ASCII value of this? ASCII value of this is 0. What is the meaning of 0? You know, in C, 0 means false. Okay, anything else, any positive number means it is true. So when this is encountered, the value of this ASCII value of this null is 0. So naturally, this part what you have here will become 0. 0 means false. False means, you know very well, this loop will break. As simple as that. Let me increment the I by putting I plus plus. Let's do the for loop. So what are the things that we are doing? So whenever we will start with one value here, so we will extract 1 from here. So we will extract one character from here. So for example, let me write that thing. So we are going to say expression expr of 0. When I is equal to 0, expr of 0 will return the value. Remember, it is a string, so it is just a character, just a string. It is a character, it is not the number 4, it is the character 4. Okay, so what you get is 4. Now this 4, if it is a digit, you are going to push it into the stack. In the same way, if it is 5 is a digit, you are going to push it into the stack. So as long as these numbers, whatever you are extracting, if it is a digit, you push into the stack. How do I check that the given value, given character is a digit or not? You are very familiar in C that there is a built-in function is digit. That's going to check whether the given character is digit or not, is upper, is digit, is lower. You studied about these functions. And where do you find these functions? These functions are found in a header file, and that header file is called as a ctype.h. So you need to include ctype.h in order to check whether the given character is digit or uppercase, lowercase, or special character or anything. You've done this in your C program. So I'm going to go over here and I'm going to say if is digit. From where did I get this function is digit? Is digit, I got it because of inclusion of this header file. So is the digit of expression of I. So if this expression of I, for example, when I is equal to 0, expression of I is going to give you 4. So is a digit 4? The answer is true. If it is 4, if it is a digit, push it into the stack. How do I write that thing? So I'm going to say push this element into the stack. Push expr into the stack. You're going to write this. However, this looks good. So you take this element, you check whether, remember this is a character, it is not just for, it is for in a single quote. It is a character, it is not the numerical for, it is the character for. So what is the ASCII value of 4? You know very well ASCII value of a small case A, you will say that that is 65, 95 and so on and so forth. You say many things about the ASCII characters. Okay, so you know that thing. So what is the ASCII value of 4? So I don't know, but I know that ASCII value of 0, this is not the null. ASCII value of 0, 0, 1, 2, 3, 4. You have these numbers 0, 1, 2, 3, 4. So similarly, so ASCII value of 0 is there. So let me start from here. So ASCII value of the character 0. What is the value of that? ASCII value of the, let me just write it here only. ASCII value of 1, what is it? ASCII value of 2, what is it? ASCII value of 3, what is it? ASCII value of 4, let me put that 4, what is it? ASCII value of 5, what is it? Okay. You must know that. I know that because I referred the internet. I know that the ASCII value of 0 is 48. How do you say that ASCII value of a capital A is 65 and ASCII value of 65? ASCII value of a small case is 97 and so on so forth. You know those values. Similarly, ASCII value of 0 is 48. Definitely, what is ASCII value of 1? ASCII value of 1 is 49. ASCII value of A is 65. What is the ASCII value of capital B? Capital B ASCII value is 66. You know that, this story. It's a continuous number. What is the ASCII value of 2? ASCII value of 2 is 50. What is the ASCII value of 3? ASCII value of 3 is 51. What is the ASCII value of 4? ASCII value of 4 is 50. 2. Now, in my program, you know that ASCII value of 0 is 42, I mean, it was 48, the ASCII value of 4 is 52. Now, if you just push this element directly, if you take one element and if you directly push, if you directly take this element and if you push, you take this one and if you push it into the stack, what is pushed into the stack? By the way, this stack is of a type integer, remember, S is of type integer. So if you push them into the stack, what is stored in the stack is not 4. ASCII value of 4 is stored. What is ASCII value of 4? Is 52. 52 is stored. So your answer, you will get a very strange answer. What is the value that you are supposed to store is 4. How can I store 4 here? Okay. So let us start with the, again, the story of this one. ASCII value of, I'm going to just write this ASCII value of 0, that is digit 0 is 48. ASCII value of digit 1 is 49. ASCII value of digit 2 is 50. ASCII value of digit 3 is 51. ASCII value of digit 4 is 52. So what I'm going to do? I'm going to subtract the ASCII value 4. ASCII value, this is a character 4 I'm going to subtract it the character. Remember, this is not 0. This is a character 0. Whenever you put something in the single quote, it is a character 0. So I'm going to subtract the character 0 from character 4. What is the value of character 4? ASCII value of character 4 is 52 minus what is the character value of ASCII value of character 0 is 48. So what is the answer? 52 minus 48, the answer is going to be 4. This is not this 4. This is not the character 4. It is the number 4. This is the integer 4. This value is integer 4, not the character 4. So when you subtract 48 from this 4, you get the actual value. So what is the ASCII value of, let me continue from here. What is the ASCII value of character 5? You know very well. ASCII value of character 5 is 53. How can I get the numerical value 5 here? So from this character 5, subtract the character 0. So what is the character value of 5? Character value 5 is 53 minus what is the character value of, or the, sorry, character, not character, the ASCII value of this 0 is 48. So you just write 48. So what is the difference between these two? Is going to be 5. So how do you get the numerical equivalent of a character digit? Subtract 48 from here. Now during the examination, you may not remember what is the ASCII value of 0. So what you will do, you don't have to by heart, just subtract this character 0 from here. How I did it here, do the same thing, just subtract the character 0 from there, from the given digit. So what is that I am supposed to do here? So I have the, where is it gone? I have the expression here. So expression of I, in this case the expression of I is character 4. I am going to subtract the character 0. It is not O, this is 0, character 0 from here. So my program will now look like whatever it can be 4 when I is equal to 1, this may be 4. When I is equal to, it may be 5, it may be 6, it may be any number. Okay, any number minus character 0. This must be pushed into the stack. So I'm going to write any number minus the character 0. It is not O, character 0. This I am putting. So when you subtract 0 from the given digit, you will get the numerical equivalent. So this is what I have done. So this is if, what is it? If it is a digit. So if it is a digit, you are supposed to, here, you are supposed to push it into the stack. So this is what, if it is a digit, you just push it into the stack. Definitely subtract minus 0 from here, the numerical equivalent of that. So in a simple word, just a numerical equivalent, you push it. Now what you get is an operator. So if it is an operator, so you cannot push it into the stack, you keep it separate. Now pop two element from the stack. So pop the first element and then pop the next element from the stack. Pop two element and then apply the operator. So whichever operator you have, apply the operator on the top two element of the stack. So just assume that the pointer was here. So you know that stack, I hope you know how the stack is working. So I will not concentrate much on the stack. So you pop two element from the stack and then, so first element you pop it, second element you pop it, okay, and whatever operator is there, you apply the operator on that, whatever answer you are getting. So 5 into 6, this answer is going to be 30. So this answer is going to be 30. This 30 you again push it to the stack. So whatever answer you are getting, push it back to the stack. Now very important thing that you must remember over here is, let me just push them here. So let me get this original 4, 5, 6. So let me do this one, 4, 5, 6. This was it. So look at here. I'm going to just put them back. This was 4. This was 5. This was the original story. 4, 5, 6. Star and plus. So this was it. This was the thing. Okay. So you take the first element, you push it. You take the second element, you push it. You take the third element, you push it. So when you pop, which element is going to come out first? It is not the first element. It is not the second element. It is the third element that is going to come out first. Again, if you pop, it is the second element that is going to come out first. So why I am stressing on this point? This is very, very critical thing in this entire thing. So when you pop, you get it in the reverse order. So let me put them back here. 4 was the first element, 5 was the second element, 6 was the next element. So when if you want to apply, suppose if this was minus here, just assume that this is minus here. This minus because it is an Excel, I can directly type minus there. So if it is minus here, so it is 5 minus, what is the answer of this? This is 5 minus, because it is minus 5 minus 6. The answer is 5 is this first element, 6 is the second element, and minus must be applied to this. Now let's look at the stack and let's try to get it in the stack. So you push first element into the stack, you push the next element into the stack, you push the next element into the stack. When you get it back, the 6 will come from first, and then again if you pop, 5 will come first. Now generally what people will do is the 6 came first, okay, then 5 came next, I am going to apply this. So this becomes a 5, 6 minus 5. But what was required? What was required was 5 minus 6. Look at this one. This is 5 minus 6. So when you get it in the reverse order. See to it that you maintain the order. So the one that you are popping first, is the second element. One that comes next is the first element. It is 5. 6 came first, but it is the second element. 5 came next, but it is first element. And then apply it here. If you do it in the reverse order, you will get a negative answer, or if it is a division, you will lose the entire answer altogether. Okay, so be careful. When you are pushing it back, the first element to come out of the stack is the second element in this order. Okay. Next one is the first element. It comes in the reverse order because it goes 5 goes first and 6 goes next. So this is the next element. This is the last element. So last element must come last, and then it must come here. So it is this order, you must maintain it. So let's go ahead and let's do that thing. So what we are going to do is we'll take two variable here. I will call it as x and y. Okay. Let me take the value. So I'm going to say x is pop the element from the stack. So pop this element. So pop the next element. Y, let the y be the second element. Remember, they are in the reverse. Let me pop them. Okay. So they are in the reverse order. So which one is the first element in this case? Y is the first element. Remember, it came in the reverse order. X is the last element. This is last but one. So X, if you are pushing, so 5 is there in the stack and 6 is there, then 4 is there. When you pop, X will be 6. This is the second element. 5 will be y. It is the first element. So you have to do it in the other way around. It is y minus x, not x minus y. So be careful with this one. So because x is the second element, the last one element is this order. So maintain that order. Okay. So let's go ahead and let's use the expression now. What we have, the situation is, let's put it here. 5 was here, 6 was here, and this was supposed to be star. So let me go back to the original story. This was star here, so I will just make it as star. It was star there. Okay, so I have the expression of 3 is star. I have popped the this element. This is where is this? This is x that I am popping out. Then this is y. So x is this one and y is this one, and I have to multiply them. So if this is a multiplication, if it is a subtraction, I have to subtract it. If it is addition, I have to add it. If it is a division operator, I have to divide it. So depending upon what is this expression value, you perform the action. So I'm going to use a switch here. So switch on the value of expression. So switch on the value of expression. So if this ex bar of I, if it is star, you multiply it. If it is plus, you add it, you subtract, and so on and so forth. So I'm going to go with the different cases of switch. The first case is, let me go in the order. First case is positive. Now this is not a double quote, sorry, because it is a character, it is a single quote. So this is if the operator is plus. So instead of I'm use star here, if it is plus, you have to add it. So how do you add it? It is the other way around. Y plus x. Don't get carried away by x plus y. Remember, the y is the first one, x is the second one. Now you add this element 5 plus 6, whatever it is there, you multiply whatever it is, then push them back. For example, you take this 6, you take this 5, and you take this the operator. 5 into 6 is 30. Whatever answer you are getting it, that you push it back again into the stack. So whatever answer you are getting, in this case if it is plus, you push it back to the stack. It's so simple as that. You push it back to the stack. After that, you know very well the case, this case ends, adding case ends. Similarly, I'm going to do it with the other. Let me just I formatted it, right click and you get the format, so it will format neatly. So this is the first case. Let's go with the second case. So if this one is if this is plus, you are adding it. Suppose if this is minus, then subtract it, as simple as that. Okay, so you don't have to, so I don't have to tell you. If this is a plus, you add it. If this is minus, you subtract it. This is star, you multiply it. So if this is minus, you subtract it. Okay, what about the next case? So let's go with the next case. If it is a star, you multiply it. So simple as that. Okay, so if it is star, x into y. What if it is division? Now when you divide it, generally you have to, where is the most pointer? Okay, you have to check whether y, the x is not equal to 0. I will not do that. If x equal to 0, you will get a division by 0 error. So this I will not do it because it simply increases the length. Now there is one more thing that you have. What are the basic operations that you generally perform? You have this plus, minus, star, this, and you have x to the power y. For example, you have 2 to the power 2. What is 2 to the power 2? 2 to the power 2 is 4. Okay. Similarly, 4 to the power 2. Okay, what is 4 to the power? 4 to the power 2 is 4 square. Okay. Similarly, x to the power y. You can also get x to the power y. Now, I cannot write x to the power y like this. It is not possible. So, I am going to use this symbol, caret symbol. Where do you find the caret symbol? On your keyboard, you have the number 6. So you have the keyboard 6. The near the 6, you have this symbol, caret symbol. Okay, the up arrow kind of thing. So I'm going to write like this: x up arrow, that is the caret symbol, y. What is the meaning of x up arrow y? Is x to the power y. Okay, so if I write 4 up arrow 2, what is the meaning of it? It means 4 square. Okay, so I will go for one other case, control C and control V. And what is this other case that I'm going to do is this is the caret symbol. If you get this caret symbol, so this is the symbol, So if you get this symbol, this is caret x to the power, that is y to the power x. So in this case, it is the other way around, y to the power x. Okay. Now you write like this and you say, oh yeah, this is done. This you are going to get a error if you try to do it, because in C, this character writing y to the power x is not there. In C, you can't evaluate, if you say to the C compiler that x to the y to the power x, compiler will say, what is this operator? I don't know anything of this operator. So then how can I get x to the power n in C program? You know very well, in C program under math.h you have a function called as a power. Okay, so x comma n, power x comma n means x to the power n. So similarly, if I write power 4 comma 2 means, what is the meaning of this? This is 4 to the power 2. So this is the power. Where do you find this one? This is available in math.h. So I will just go up and I'm going to include math.h there. So now you have to come back and you have to change this. So this will not work. The function is power x to the x comma y. So x comma y, and then put this one. So this is the function power x comma y. So what is this power x comma y means? It means y to the power x. Okay, so that is it. E to the power x. If this is 2 and if this is y is 3, so this becomes 2 to the power 3, which is going to be 8, and so on. Okay. So this is done. What is the last thing that you are going to do? So remember, after evaluating all the expression, finally you will get some value. Let's say -4. I'm just giving the answer. This is the last. So you take you pop two element, apply the operator, and you keep on doing like this. Whatever is the last value, that is the result of evaluating the expression. So pop this one, last one, which is remaining, pop this will be the last final result of evaluating that expression. So the 34, I've just written this is 4 5 6 star plus the answer is 34. So when you evaluate this whole thing, when this whole thing you pop up and you apply, pop and then apply and so on, the last thing that will be there in the stack is 34. Okay, you pop that 34 and you will say that that is the result of the expression. So the last thing, so this is my function. Where is the function? So this is my function. Just keep the mouse pointer, see the keep the mouse pointer here. Okay, and you see it is blue in color. You go down and you see that the closing bracket is also this one. Before that, this is the closing of this thing. Okay, so before that you just return. So you say return. What are you going to return? Pop the last element. The 34 will be the last answer which will be there in the stack. Just pop that element and then that is the end of it. So this is your evaluation function. Now what is left over is writing the main function. I'm going to quickly write the main function, and main will not return anything back to me. So I'm going to say main, and I need an array. That's all. I want just an array. Let me say character, and I will call it as expression. And let's say 25 character. I don't think so you will write more than 25 characters during the examination. Let me put a printf statement, and let me ask the user enter a postfix expression. So let's ask the user to enter a postfix expression. I'm going to use the scanf function. So very important thing over here, and I'm going to read a string, okay, into this expression. I'm going to read a string into the expression. What is why did I say very important over here is, you know very well, if you write like this, so 4 5 6 star plus, this is going to work. However, if you write this 4 5 6 then put a space, then star and plus, you know very well, whenever the scanf with this percentage yes, whenever it encounters a space here, it will read only this much part. remaining it will simply ignore. So be very, very careful during the examination. It is a single word. Do not put the spaces in between. So you just you cannot put 4 space 5 space 6 6. This will not work because it will simply read 4 here, and once it encounters space, it will ignore the remaining part. So with the scanf percentages, you can put the spaces in between them. So it is a single word that you are typing, not the spaces in between them. So this is very, very critically important. Okay, so let's go ahead with the result now. So I'm going to just say the result is percentage D. I assume that you're going to get the result, and you know very well this evaluate, this function evaluate, the last thing it is going to return, this return is the final result. That is what I told you, evaluate the expression. So the expression whatever we are reading, just evaluate the expression. So that's simple as that. So let me save it and let's see whether it really works well. Okay. I have an sometime, you know, sometimes you get this kind of error and you don't know what is the error. It just stopped here with the red color. So what to do? Don't get panic. Go to view and go to logs. You can press F2 here and it's going to tell you that you have put one extra comma there. So just put that. Yes, save it and then try one more time. If there is one more error, what is the error you have? Okay, I just removed this I and I put this I. That I was there, counter variable I was there. I just removed that I. Okay, just hopefully there are no more errors. Okay, done. Let me try with my built-in functions over here, and that is 456 star plus. So I'm going to type, remember, single word 456 star plus. I press enter and I get the answer 34. Okay, let me try. See, let me try one more time. Let me just run it one more time. And you know, if I just type like this, 3 4 plus, what is the meaning of this 3 4 plus? 3 plus 4, what is 3 plus 4? You know, this is going to be 7. Will I get the answer if I try that thing? So 3 4 plus and press enter, you get the answer as a 7. Okay, let me try with the slightly complicated. I don't know, I hope this is a complicated one. Remember, it must be a single word. I'm going to just copy Control C from here. I'm going to just run it to this one, and I'm going to just paste it and press enter. Hopefully, so this answer is -4. This is -4. So this is a evaluated one. I got it from the net where it has been try tested. There was one website that was doing it here. Thanks to this calcont.in somewhere. Okay, calcont. It actually has the function that you just put it here. It will evaluate it. Okay, write any expression, correct expression, not the wrong expression. It will convert. There are a lot of conversions available over here. Thanks to this website, whoever has designed it. Again, I'm not promoting, they're not paying me for doing it. So just, but they have done appreciable good things, so I have to appreciate it. So that's all in this exercise. Thank you for your interest. We will meet again in the other exercise. Thank you.